Solve the equation sine of 2x minus pi over 3 equals negative 1/2. The angle inside of sine is 2x minus pi over 3. This looks a bit complicated as an equation because of 2x minus pi over 3. Usually we are used to sine of theta, and so to make it simple, we let theta be 2x minus pi over 3. This equation is now simply sine of theta equals negative 1/2. Wouldn't it be much simpler? But remember, we're not looking for theta, we're looking for x. Once we obtain a simple looking equation, we would go to the unit circle and read off the solution. Sine is the y coordinates, so we would draw the line y equals negative 1/2, and we read off the angles between 0 to 2 pi. From the positive horizontal x-axis, the first angle, and then the second angle. Sine of theta equals negative 1/2 only when theta equals 7 pi over 6, and again 11 pi over 6. Although these are the principal solutions, and so we might want to write these as 7 pi over 6 plus 2k pi because the period of the sine function is 2 pi. We do a back substitution. Remember that we're not looking for theta but x, where theta equals 2x minus pi over 3. We set it equal to 7 pi over 6, but again, we need to add 2k pi. We will need to do this every time there is a constant multiple in front of x that is not 1. We next isolate x. 2x equals pi over 3 plus 7 pi over 6 plus 2k pi. This will give us 2x equals pi over 6. We multiply 2 over 2 to get 2 pi over 6. 2 pi over 6 is 1 pi over 3. 2 pi over 6 plus 7 pi over 6 is 9 pi over 6. And we still have 2k pi. But 9 pi over 6 is 3 pi over 2, divided by 3 top, divided by 3 bottom. Isolating x, we have x equals 3 pi over 4 plus 2k pi divided by 2 is k pi. We will need to find x by substituting k for 0 plus or minus 1 plus or minus 2, but the angles that we're looking for are positive angle, so we will plug in 0 or positive integers only. Specifically, when k equals 0, we have x equals 3 pi over 4 plus 0 pi, which is 3 pi over 4. When k equals 1, x is 3 pi over 4 plus 1 pi. 3 pi over 4 plus 4 pi over 4 is 7 pi over 4. When k equals 2, x is 3 pi over 4 plus 2 pi, but this is more than 2 pi, so we don't need to include it. We're looking for x from 0 to 2 pi only. So we found 2 x values already. We repeat this with 11 pi over 6. Remember that we only set theta equal to x minus pi over 3 equals 7 pi over 6, which is one of the solutions. Doing this again, but this time, when theta equals 11 pi over 6, we have 2x minus pi over 3 equals 11 pi over 6, and we add 2k pi because the period of sine is 2 pi. We isolate 2x to get 2x equals pi over 3 plus 11 pi over 6 plus 2k pi, but pi over 3 is 2 pi over 6. 2 pi over 6 plus 11 pi over 6 is 13 pi over 6. And so x itself is 13 pi over 12 plus 2k pi divided by 2 is now k pi. And we plugged in k equals 0. When k equals 0, x is 13 pi over 12. When k equals 1, 13 pi over 12 is more than 1 pi. Add another pi would give us more than 2 pi, so we don't need it. We will need to check the negative k values as well, because this x is more than 1 pi, and because of the minus pi over 3, we will need to make sure that there is nothing before x equals 13 pi over 12. And to do that, we will let k be negative 1. Then x equals 13 pi over 12 plus negative 1 pi, which is 1 pi over 12. And 1 pi over 12 is well in the interval 0 to 2 pi. And so if we didn't check k equals negative 1, we will lose one necessary solution. When we plug in k equals negative 2, then 13 pi over 12 minus 2 pi will give us a negative x. And we only need x between 0 to 2 pi. We summarize the results by listing all of the x values that we found in the interval 0 to 2 pi. They are the smallest one, pi over 12, next 3 pi over 4, next 13 pi over 12, next 7 pi over 4. These are the 4 x values that are in 0 to 2 pi interval.